Welcome to the NEAF Talks podcast, written and presented by the Rockland Astronomy Club. This month's podcast takes us on a deep dive on what we can expect to see in the February night sky. Whether you're a backyard observer with a trusty Dobsonian or a deep sky imager chasing the perfect exposures, you know that the heartbeat of the hobby is at the Northeast Astronomy Forum. I'm thrilled to introduce your guides for today's journey through the stars. Joining us is our very own Julian Edwards. Julian is a voice actor and a veteran of the night sky. His many years as an astronomy enthusiast has given him extensive knowledge of celestial mechanics and deep sky objects from Messier and Caldwell to NGC and beyond. And alongside him, we have Elana Mikhailov, an astrophysicist and educator from New York, known for her skill in bridging the gap between complex data and the beauty of the night sky. Julian, Elana, take it away.
Welcome to the Deep Dive, your express ticket to being the most informed person in the room. We've gone through the celestial forecasts, the mission profiles, everything for February 2026, and we're ready to unpack a month that is, well, it's performing on two spectacular stages.
It really is a phenomenal confluence. I mean, on one stage, you have the pure cosmic mechanics, these rare planetary alignments, the closing act for the winter deep sky.
And on the other?
On the other, you have humanity's long-awaited, critical next step back to the moon. What's so fascinating is how these events demand such a gradient of attention, from just stepping outside to the most advanced gear.
That's exactly our mission for you today, a structured conversational guide. We're going to navigate the best viewing opportunities, really understand the science behind them, and connect all these celestial happenings to the broader story of space exploration.
Right. We're moving from a 7-planet parade all the way to the Rosette Nebula, while also, keeping one eye glued to that launch pad in Florida.
So let's jump right in. Let's start with the solar system's grand gesture, which really culminates at the end of the month.
Let's do it.
Okay, let's unpack this huge event. On or around February 28th, all 7 major planets, Mercury, Venus, Mars, Jupiter, Saturn, Uranus, and Neptune will all be visible in the sky at the same time. It sounds like a calendar marker.
Yeah.
You just can't miss.
It is a calendar marker, but we have to immediately clarify a crucial insight here. It's spectacular because of our vantage point. What we're seeing is a visual effect, an optical illusion of perspective. This is absolutely not a syzygy, which is, the technical term for when celestial bodies are physically aligned in a straight line in 3D space. That's simply not what's happening.
So if they aren't lined up in space, why does it look like they are? What are we actually visualizing here?
We're seeing a visualization of the solar system's main plane, the ecliptic. Think of the solar system as a giant, flat dinner plate. All the planets orbit roughly on that plate. When we look up, we're seeing that plate edge on, and it looks like a massive, subtle arc across the sky.
Ah, I love that dinner plate analogy.
The planets are scattered all around the sun, but from where we're standing, their positions put them all along that visible arc.
So they're not clustered together. They're spread out in this string of pearls you mentioned. That's a stunning way to capture the whole architecture of our cosmic neighborhood in one glance.
Exactly. It's our perspective that makes it so special. Now, seeing this whole parade, it requires a bit of strategy. The gear you need ranges from 0 to highly specialized.
Let's start with the easy ones then, the naked eye anchors.
The 3 easy wins.
Okay, start on the western twilight. You'll find Venus right away. At magnitude min of 3.9, it's just a brilliant anchor. You can't miss it, even with city lights.
Then you just swing over to the eastern or southeastern sky. Jupiter will be completely dominating over there, blazing at magnitude minus 2.5. It's still incredibly bright from its opposition back in January, still commanding the night. Now for what we're calling the Twilight Challenge. This is where things get tricky because the sun is fighting back. Both Mercury and Saturn are very low in the western twilight. Mercury is fading.
It's past its best, right?
Right. It's magnitude plus 1.1, just past its best elongation. And Saturn is incredibly low. It's sinking towards solar conjunction.
So the sun's glare is definitely the enemy here. Spotting them is all about timing and a clear horizon.
Yes. You need to scan the horizon with binoculars immediately after the sun finally dips below it. And of course, the standard safety warning.
Never aim optics at the sun.
Never. Not even when it's on the horizon. But that very brief window after sunset is your only shot at Saturn.
Okay, so that's 5. What about the last 2? For the completionists.
The optical requirements. The two ice giants. Uranus at magnitude plus 5.8 is a binocular or small telescope object. If you know Taurus, look for it near the Pleiades cluster.
And the final piece of the puzzle, the hardest one to check off the list.
Neptune. It's strictly telescopic. At magnitude plus 7.9, you will absolutely need a 4-inch or larger scope and some good star charts to pick it out. It's over in Pisces. So if you see all 7, you've basically completed a masterclass in solar system viewing.
That Grand Parade is an epic closing act, but let's dial back a bit to the middle of the month. There are a couple of events for the true celestial connoisseur, starting with Mercury's greatest eastern elongation on February 19th. The sources are calling this arguably the most favorable evening apparition of the year for us in the northern hemisphere.
And here's where it gets really interesting, because the angular separation, 18.1 degrees from the sun, isn't actually the widest Mercury ever gets. If you just looked at that number, you might think a summer elongation is better. But the magic, like we were just talking about, is the geometry of the ecliptic.
So it's not just about how far Mercury is from the sun, but where that arc hits our horizon.
Precisely. In late winter, the angle of that ecliptic plane is very steep relative to the western horizon. That geometry acts like a ramp. It just lofts Mercury high up into darker sky.
Right, so an autumn elongation might be wider, but the angle is shallow, so it's stuck skimming the horizon through all the haze.
Exactly. The key insight is that on February 19th, Mercury will be nearly 16 degrees above the horizon at sunset. That makes it so much easier to spot. That steep angle makes all the difference.
And the sources say it's also incredibly photogenic.
Oh, absolutely. On the 18th and 19th, a thin, beautiful, waxing crescent moon, maybe 5 to 8% lit, will be right there with Mercury.
That sounds like a must capture for anyone into nightscape photography. So a tripod and a 200mm lens?
A modest 200mm lens is perfect. You can capture the Earth shine on the moon, that ghostly glow alongside that piercing dot of Mercury. It's a stellar shot with pretty standard equipment.
Okay, speaking of technical challenges, let's pivot to something really difficult. The Saturn and Neptune conjunction on February 15th, they'll be separated by less than a degree.
It sounds like a gift, right? 2 planets in one field of view.
It does. But you mentioned a massive technical hurdle, the extreme contrast problem.
Yeah, and this really gets at a fundamental question. Why is seeing a faint object next to a bright one so hard? Saturn is shining at magnitude plus 1.1. Neptune is nearly 525 times fainter at magnitude plus 7.9. The problem isn't the distance between them. It's the optics.
525 times brighter. That seems impossible for most backyard scopes, isn't it?
It is if your gear isn't optimized. Saturn's brilliance causes light scatter and internal reflections inside your optics, in the tube, off the lens, inside the eyepiece. Those reflections just hide that faint blue dot of Neptune in a cloud of glare.
So if the solution is gear, is this only for people with 5-figure telescopes, or is there a budget trick our listeners can try?
That's a fair question. The quality of your eyepiece coatings is really critical here. High-end eyepieces, like Televue, Delos, or Ethos, they're expensive for a reason. Their coatings minimize that scatter. But if you don't have that gear, the budget trick is simple. Place Saturn just outside your field of view.
Oh, okay.
Yeah. Use a star chart to see where Neptune should be. Let Saturn drift just off the edge of the eyepiece, and then look for the faint, steady star that's actually Neptune. It minimizes the glare hitting your eye directly.
As we shift from the solar system to the deep sky, February really feels like a last call for the classic winter jewels.
Yeah.
Orion and Taurus are starting that inevitable shift west. This is the last prime month for those long exposure projects.
It is. It's the closing act of the winter show. And our headline act this month, especially with the theme, has to be the Rosette Nebula. It's cataloged as NGC 2237 in the constellation Monoceros. We're calling it the Cosmic Red Rose.
The Rosette is just east of Orion. And what's wild here is its sheer scale. It's not some tiny target.
Yeah.
It's massive, right?
Oh, it's absolutely huge. It spans about 1.3 degrees across the sky. To put that in perspective for you, that's roughly 3 full moons wide.
3 full moons.
Which tells you something important. It tells you that you need a wide field of view. If you try to use a big, high-powered telescope, you'll only see a tiny piece of one petal.
So the right tool is key.
Yes. The Rosette is an ideal target for wide-field short-tube refractors. You know, those compact, specialized scopes like a William Optics Red Cat or something from the Asker series. You need a short focal length to capture the whole rose in one frame.
Beautiful. And while we're in the neighborhood, we have to talk about the anchor of the winter sky, the Orion complex. Everyone knows M42, the Great Orion Nebula. It's the closest massive star-forming region to Earth.
And visually, M42 presents a bit of a paradox. If you look at it through a telescope, it looks, well, it looks greenish-gray. And the reason for that is just basic human biology. Our low-light sensors in our eyes, the rod cells, they aren't sensitive to the specific red light called H-alpha that dominates the nebula in photos.
So what does that mean for the astrophotographer who wants that stunning, vibrant red picture?
It means they have to deal with the challenge of M42's brightness. It's so bright that its core, the trapezium stars, they often blow out or overexpose almost instantly. The solution is to master HDR compositing, high dynamic range imaging.
How does that work in practice?
You combine exposures of different lengths. You take super short exposures, maybe half a second, just for the bright core, the trapezium. Then you take much longer exposures, minutes long, to capture all the faint outer dust. You combine those two images later to get detail in both the bright and dim parts at the same time.
A great technique to master this month. And just south of Orion's belt is the elusive Horsehead Nebula, IC 434 and Barnard 33. There's a great filter lesson attached to this one.
There is. The Horsehead itself, Barnard 33, is a dark nebula. It's a cloud of cold dust that's silhouetted against the bright red emission nebula behind it. Visually, even with a big scope, it is nearly invisible without one critical piece of gear. A hydrogen beta filter. An H-beta filter.
And what does that filter do that makes it so critical?
It's what's called a narrowband filter. It blocks almost all other light, including light pollution, but it lets a very specific green-blue wavelength of light pass through. That specific contrast is what makes the dark shape of the horse's head pop out. It really shows how essential these filters are for amateurs hunting subtle detail.
Before we move on, let's highlight the Pleiades, M45. We're calling it the binocular object of the month.
The Pleiades are high in Taurus, and this February the planet Uranus is located pretty close to them. The educational value of this is just profound. Seeing that star cluster and an ice giant planet in the same binocular field offers this powerful, tangible perspective on cosmic depth.
Right. You're seeing objects far away in our galaxy, the stars, next to an object in our immediate solar system, a planet, all at once. That's a pretty rare and profound perspective you can get with just a simple pair of binoculars. So February 2026 isn't just about passive viewing. It's about the roaring engines of human achievement. We absolutely have to talk about Artemis II. This is monumental. It's the first crewed mission of the Artemis program, and the first time humans will go beyond low Earth orbit LEO, since Apollo 17 splashed down in December 1972.
The weight of history on this mission is just incredible. The target launch window opens no earlier than February 5th or 6th. And while we should always manage our expectations for slips, Artemis, I taught us, patience. The magnitude of this, putting humans back on a lunar trajectory, is undeniable.
And the crew, Commander Reed Wiseman, pilot Victor Glover, and mission specialists Christina Cush and Jeremy Hansen from the Canadian Space Agency. It's not just a mission, it's a cultural touchstone.
Absolutely. The cultural significance is immense. Think about it. This crew includes the first woman, the first person of color, and the first non-American to ever leave low Earth orbit. It represents a truly generational and international shift from the almost entirely American male Apollo era.
Now, they aren't landing on this mission, but the trajectory itself is a masterpiece of orbital mechanics. Can you explain the flight profile for us?
Sure. They're flying what's called a hybrid free return trajectory. After launch on that massive SLS rocket, the Orion capsule will first do 2 orbits in a highly elliptical orbit, or HEO. This orbit goes way out, up to 46,000 miles, before swinging back.
Why that? Why that very distant initial orbit?
It's a comprehensive safety and systems test that Apollo never had the luxury of doing. They'll test life support, navigation, manual piloting, all in deep space conditions far from the Earth's protective magnetic field before they commit to the full translunar injection burn.
And that translunar injection burn, the TLI, that's the point of no return. Well, the commitment point.
Correct. The TLI burn sends them on their way. The genius of the trajectory is what happens next. The spacecraft flies around the far side of the moon at an altitude of about 4,600 miles. And crucially, they use the moon's gravity to essentially slingshot the capsule back toward Earth without needing a major propulsive burn.
So it's a self-correcting slingshot. It uses physics to guarantee a return path, even if propulsion were somehow compromised.
Precisely. It's a textbook demonstration of orbital physics applied to human safety. The whole mission should last about 10 days, cover 1.4 million miles, and set the stage for Artemis III, the landing mission.
And while Artemis is grabbing all the headlines, we should briefly mention the commercial sector is still active.
Yeah.
SpaceX Crew 12 is targeting a launch around February 15th to the ISS. So a busy month in low Earth orbit as well.
Very busy.
Okay, we've covered a massive amount of ground. The Grand Parade on the 28th, the last call for the Rosette Nebula, and the historic launch window for Artemis II. What final thought or challenge should our listeners be mulling over for their February nights?
I want to introduce a challenge that really touches on how technology is changing astronomy itself. It's a comet. C2024E1, Virchas. This long-period comet reaches its closest approach on February 17th. It's predicted to be relatively bright, maybe magnitude 7.6 to 8.5.
That sounds like a perfect target for a small telescope or even good binoculars, but I'm sensing a catch: the geography.
You sense correctly. During its peak brightness, the comet is way down south, traversing constellations like Grus and Phoenix. It's a southern hemisphere object, which means it's frustratingly inaccessible to almost all of our northern hemisphere audience.
So that's the challenge.
Yeah.
How do you participate in an event you can't physically see?
This is the moment to look forward and appreciate the democratization of astronomy. There are services now, like iTelescope or Telescope Live, that have professional-grade telescopes in places like Chile or Australia. The powerful takeaway here is you can overcome geographical barriers. If you can't see the comet, you can log in, command a scope thousands of miles away, and image it yourself.
So you're contributing to the global scientific record from your couch.
Exactly.
But that truly highlights how global citizen science has become. You don't have to be geographically lucky anymore. That's a powerful and practical perspective to end on.
Indeed. Keep looking up and keep thinking critically about what you see and how you can see it.
That's all for this month's NEAF Talks podcast. We hope you enjoyed it. Remember, you don't need fancy equipment to enjoy the night sky. Your eyes, a pair of binoculars, or a small telescope can reveal wonders that have captivated humanity for thousands of years. For more information about astronomy events, equipment, and the annual Northeast Astronomy Forum Expo, visit rocklandastronomy.com and neafexpo.com. That's NEAF expo.com. Clear skies, everyone, and happy observing.